Welcome guys to this another video. In today's video we'll be looking at how to add and subtract fractions. But before we get into this video, don't forget to give this video a thumbs up, hit that notification bell to be notified whenever we post new videos, and don't forget also to subscribe to the channel. Alright, now let's get right into it. Now when we're adding and subtracting fractions, it's very important that the denominators are the same before we proceed with the addition or subtraction. So for example, if we have the fraction 4/5 minus 1/5, when we look at this fraction, guys, both the denominators are the same. They are both 5. So we can go ahead and subtract the numerators. 4 minus 1 is of course 3. And the common denominator here is 5. And let us call this example 1. Now let us look at example 2. Now what if we were adding instead? Let's say we had 2/7 plus 4/7. Again, when we look at these two fractions, both the denominators are the same. Both denominators are 7. So we can go ahead and add the numerators. 2 plus 4, that's 6. And we'll keep the common denominator here, which is 7. Now let us look at some more examples. Let's call this example 3. Now what if we had more than just two fractions? So let's say we had something like 2/10 plus 4/10 plus 1/10. Again, the concept remains the same. All the denominators here are common. All three denominators are 10. So we can go ahead and add the numerators. 2 plus 4, that's 6, plus 1, that's 7. And we can keep the common denominator here, which is 10. Now let us look at example 4. Now what if we had a mixture of addition and subtraction in the same problem? Let's say we had something like 7/12 minus 5/12 plus 3/12. Again, the concept still remains the same. Once all the denominators are common, as we see here, we can just subtract and add the numerators respectively. So 7 minus 5, of course, that's 2. 2 plus 3, that's 5. So I'll have 5 here over the common denominator, which is 12. Now let us look at a few more examples. Let's call this one example 5. Now what if we had some mixed fractions? Let's say we had like 2 and 4/5 minus 1 and 3/5. Now before we go ahead and subtract, what we could do is to actually convert the mixed fractions to improper fractions. So we're going to convert this 2 and 4/5 to an improper fraction, and we'll do the same for this 1 and 3/5. Now when we convert 2 and 4/5 to an improper fraction, we'll end up with 14/5. And if you're not comfortable with converting from mixed to improper, then please check out the description section of this video. I'll have the link to a video that we actually go in depth in teaching that concept. Alright, but just to review the concept, in converting from mixed to improper, what we actually do is multiply the whole number here by the denominator, then add the result to the numerator, and that becomes the numerator for improper fraction. So 2 times 5, that's 10, plus 4, that's 14. And we keep the denominator that is here. All right, minus 1 times 5, that's 5, plus 3, that's 8/5. Now, once it is in this form, we can go ahead and do our subtraction because as we notice here, the denominators are common. So 14 minus 8, of course, that's 6 over the common denominator, which is 5. You can also convert this improper fraction to a mixed fraction. Sometime when you're solving multiple choice questions, the answer can also be in the mixed fraction. So in converting the improper to mixed, we want to find out how many times can the denominator go into the numerator. 5 going to 6 one time. That becomes our whole number. And the remainder after we would have taken out the 5 out of the 6. That will become the numerator. So after taking 5 out of 6, we'll be left with 1. And we keep the denominator that is here, which is 5. Now let us look at another example. Let's just call this example 6. Hopefully I'm counting right. Now what if we are required to add or subtract? Let's say we had a mixed fraction, 2 3/5 minus, let's say we just had 1/5 here, which is a proper fraction. Now how do we treat with something like this? Now what we are required to do here is to first convert the mixed fraction, and notice here, unlike the previous example, we only have one mixed fraction. So we'll only be required to convert this mixed fraction here, which is the 2 3/5. And when we convert 2 3/5, what will we get? 2 times 5, that's 10, plus 3, that's 13 over 5. Minus, we don't need to convert this. This is already in a simple form, if I can call it that. Alright, it's a proper fraction, so we can just bring it down. So we carry back down to 1/5. Now we can proceed and do our subtraction because as we notice here, the denominators are common. So 13 minus 1, that's 12 over, we keep the common denominator here, which is 5. Now let us look at some example when the denominators are not the same. How do we treat with those? So let's call this example 7. Now what if we had something like 2/3 plus 1/5? Now notice here, the denominators are different. One denominator is 3, while the other is 5. Now because both denominators are not the same, we cannot just go ahead and add the numerators. We must do something first to ensure that we have common denominators, then we can proceed and add these two fractions. Now, there are different ways how we can get the denominators to be the same. Now, one of the popular methods used is referred to as the LCM method. I'm also going to demonstrate another method as well, but let's begin with the LCM method. Now, the first thing we do when we're using the LCM method is to draw a line segment underneath the two fractions, leaving a little space here because we're going to put some values on this line segment that we just drew. All right. Now, the LCM refers to the lowest common multiple. What that means is the lowest number that both 3 and 5 can go into without leaving a remainder. And however, though they refer to it as the LCM method, any multiple can actually work. All right. But it helps to use the lowest common multiple because it makes life a whole lot easier. And sometimes it saves you the trouble of having to reduce the final answer. Now the LCM for both these denominators is of course 15. That's the smallest number that both 3 and 5 can go into without leaving a remainder. Now 3 going to 15 5 times, and we'll use that 5 to multiply the corresponding numerator for the 3 here. 5 going to 15 3 times, and we'll use that 3 to multiply the corresponding numerator for this 5 right here. All right, so that's the whole procedure, guys. So the amount of times the denominator go into the 15, you'll use that number to multiply the numerator for that denominator. And the same thing applies for this side as well. Now the next step, guys, is to actually do the multiplication here. So 5 times 2, that's 10. And we'll put the 10 on the line segment right here. We'll bring down the addition sign. Then we'll go ahead and do the multiplication on this side. 1 times 3. Of course, that's 3. 10 plus 3 is 13. And we'll put the 13 over the LCM here, which is 15. And this is our final answer. Now I'm going to solve the same problem using the other method that I was telling you guys about, which I believe is probably easier than the LCM method. Allow you to probably understand the concept of adding and subtracting fractions more. All right, but let's see what you guys think of it. Now the other method that I was telling you guys about was the whole concept of equivalent fractions. Now what we want to do here is to rewrite both these fractions and equivalent fraction for both these fractions such that both of them have the same denominator. Now in doing this, there's an easy way to do it. All right, so what we can do here, if we have 5 in the denominator on this side, what we're going to do is to multiply both the top and bottom of this fraction by the 5. And because we have 3 on this side, we can multiply both top and bottom of this fraction by the 3. Now, by doing that, this allows us to gain an equivalent fraction for both these fractions that allows both fractions to have the same denominator, which you'll see in a few. All right. So we carry out the multiplications here. So we have 5 times 2, that's 10 over 5 times 3. Of course, that's 15 plus 1 times 3. That's 3. 5 times 3, that's 15. Now, if you observe here, we have common denominators. And as we demonstrated in the previous examples, once the denominators are the same, we can go ahead and add the numerators. So 10 plus 3, that's 13 over the common denominator, which is 15. Now let me know in the comment section, guys, which of the methods do you think is easier, whether it is the LCM method or the whole idea of equivalent fractions. Now let us look at a few more examples. Now let us call this one example 8. Now, what if we were actually subtracting fractions? By now you would have noticed that the difference between addition and subtracting fractions, the methods are really the same. It's just that for one you're adding and for the other you're subtracting. How ironic. Let's say we had 4 over 7 minus 110. Now how would we treat with this? Now, of course, you can pause the video here, you can try the LCM, or you can apply the whole concept of equivalent fractions, which I'm going to lean to for this particular problem. So I'm going to apply the whole concept of equivalent fractions here. Now, if we have 10 in the denominator on this side, what we can do again is multiply both the top and the bottom of this fraction by the 10. And because we have 7 on this side, we're going to multiply both the top and the bottom of the fraction here by 7. Now what we'll do next is just to carry out the multiplication. So 10 times 4, of course, that's 40 over 10 times 7, that's 70, minus 1 times 7, that's 7 over 10 times 7. That's 70. Now again, guys, we have what we're looking for here. We have common denominators. Both denominators here are 70. So we can go ahead and do our subtraction. So 40 minus 7 is, of course, 33 over the common denominator, which is 70. Now let us look at another example. Now let us look at example 9. Now what if we had 7.5 plus 2 and 5/6? Now how would we treat with a problem like this one? Again, the advice is once we have any mixed fraction involved in the problem, it always helps to convert those mixed fractions to improper fractions. So we're going to convert this 7.5 to an improper fraction, and we'll do the same thing for this 2 and 5/6. Now when we convert 7.5 to an improper fraction, we'll end up with 15/2. We bring down this addition sign here. When we convert 2 and 5/6 to an improper fraction, we'll end up with 17/6. Now from here we can either go down the LCM route, or we can apply the whole concept of equivalent fractions. Now if we should apply equivalent fractions in this case, it doesn't have to be like the previous examples. What do I mean by that? Of course we can multiply this side by 6, both top and bottom by 6, and this side both top and bottom by 2. However, we don't have to do that. Why, you might ask? Because 2 is a factor of 6, which means that 2 can go into 6 without leaving a remainder, which means we can multiply 2 by something, some number out there, and get 6. Of course, that number is 3. And we'll multiply both top and bottom by the 3. Remember guys, all we're doing here, this step is all geared towards having both fractions with the same denominator. So 3 times 15, that's 45, over 3 times 2, that's 6, plus 17/6. And of course guys, this is what we want. We want to see common denominators. And once we have that, we can go ahead and add the numerators. 45 plus 17, that will give us 62 over the common denominator, which is 6. Now let us look at example 10. Now what if we had 7.5 minus 2/3 plus 2 and 1/5? Now how would we treat with an example like this? Again, the advice is to convert all the mixed fractions to improper fractions. So we'll convert the 7.5 and the 2 and 1/5 to an improper fraction. Because this is a proper fraction, we'll just leave it as is. When we convert 7.5 to an improper fraction, we'll end up with 15/2 minus 2/3. So we'll just keep the 2/3 here. Bring the plus sign here. 2 times 5, that's 10, plus 1, that's 11/5. Now from here, we can either use the LCM method or the whole idea of equivalent fractions. Now I'm going to demonstrate both, but let's start off with the LCM method. Now let's draw a line segment here. Now what we want to find here is the LCM for 2, 3, and 5. And of course that's 30. And again guys, LCM refers to the lowest number that all these denominator can go into without leaving a remainder. Now 2 into 30 goes 15 times. So we have 15 times 15 here. 3 into 30 goes 10 times. 5 into 30 goes 6 times. Now 15 times 15, that will give us 225. Bring the minus sign here. 2 times 10, that's 20. Bring the addition sign here. 6 times 11, that's 66. Now 225 minus 20, that's 205. And 205 plus 66, of course, that's 271/30. And that's pretty much our answer. Now let's try using the whole concept of equivalent fractions. Now if we were to use the equivalent fraction method to solve this problem, what we'll do to determine which number will multiply both the numerator and denominator by for this particular fraction, which is 15/2, we'll just find the product of the other denominators. So for example, if we want to find the number that will multiply both the numerator and denominator by here, we'll find the product of 3 and 5. 3 times 5, that's 15. Therefore, we'll multiply both top and bottom on this side by 15. We'll repeat this step for the other two fractions. So if we want to find the number to multiply both the numerator and denominator by here, we'll find the product of the other two denominators. So that's 2 times 5, which is 10. So therefore, we'll multiply both top and bottom by 10. And of course, it applies for this one as well. So if we want to find which number we're going to multiply both the 11 and 5 by here, then we'll find the product of the other two denominators. 2 times 3, of course, that's 6. So we'll multiply both top and bottom here by 6. From here, the rest is history. We'll just carry out our multiplication. So 15 times 15, of course, that's 225 over 15 times 2, that's 30, minus 2 times 10, that's 20, over 3 times 10, that's 30, plus 11 times 6, that's 66, over 5 times 6, which is 30. And again, guys, this is what we're looking for. All three denominators are the same. So we can go ahead with our subtraction and addition respectively. So 225 minus 20, of course, that's 205. 205 plus 66, again, that's 271. Over the common denominator, which is 30. So again, we got the same answer, just like when we use the LCM method. And this is where we'll be ending this one, guys. Don't forget to hit that subscribe button. Give this video a thumbs up and hit that notification bell to be notified whenever we post new videos. I hope that this video helped you guys to better understand how to add and subtract fractions, whether it be like or unlike denominators. Until next time, blessings and peace.